Okay, we can start now. Hello everyone. Good morning, evening, and afternoon as well. Dear authors and invited guests, I welcome all of you to Technical Session 8F. My name is Amok Damdere, and this session would be moderated by me. And on behalf of the Global Knowledge Research Foundation and GR Scholastic, it is a great pleasure to welcome all of you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026. The 11th edition of this conference is being organized in a hybrid mode. The physical event will be held today in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April 2026. I hope all of you will be enjoying the knowledgeable and interactive sessions we have planned throughout the day. In this particular session, we will be having 10 presentations where each presenter will be given 10 minutes for their presentation and 2 minutes for questions and answers. And on the completion of around 8 to 9 minutes, I will be raising a gentle reminder as well. Uh, there is another request to all the participants that all of you please stay connected with us until the end. And if you have any queries or updates, you can write it to me in the chat box. Uh, Before starting, I would now like to introduce our session chairs for today. So our first session chair for today is Professor Shaklo Rustamovna Abdullah. Abdullah, I apologize for any mispronunciations. Professor Shaklo Rustamovna Abdullah is a professor in the Department of Economics at the Tashkent branch of Plekhanov Russian University of Economics in Uzbekistan. With over 25 years of experience, she specializes in labor economics, social policy, and international relations. Her research focuses on labor market modernization, socio-economic development, and social protection, contributing to policy-oriented and sustainable economic advancement. Ma'am, we welcome you here, and I request you to give us your opening remarks.
Good morning for all participants on the conference, and to me it's a great honor to participate and to be a chair of session. Yesterday was the first day and it was very interesting discussion. I also participate with a speech and present our experience in Uzbekistan, how development artificial intelligence. So it was very interesting, and I would like to express my gratitude to organizers of such kind of conference, because to us academician workers, it gives a very good chance to speak and to see what researchers, what happened in other countries. So very interesting organization, very good speakers, and very interesting the whole picture and the structure of the conference. So I wish to all participants good success and welcome, and to share with your experience and your scientific research's results. Thank you very much.
Thank you so much, ma'am. It's great to have you with us. Our next session chair for today is Dr. Rashmi Kare. Dr. Rashmi Kare is an assistant professor in the electrical engineering domain at Vishwakarma Institute of Technology in Pune, India. Her academic and research interests include power electronics and power systems. She is actively involved in teaching, research, and technical publications. Dr. Kare contributes to academic excellence and innovation in electrical engineering education at VIT. Ma'am, we welcome you, and I request you to give us your opening remarks, please.
Thank you, Abuk, and thank you, ICTIS, first of all, for inviting me as a session chair for this esteemed event. And I welcome all the participants, and we will have a nice and good discussion regarding research and the innovation, that how we can proceed with the research work in the future as well, new ideas and new discussions. I am hoping for the good initiative from each and everyone, and I wish all the very best to all the participants, and over to you. Thank you, and thank you for inviting me for such an esteemed event, and all the very best for the entire session. Over to you.
Okay, thank you so much, ma'am. It's great to have you with us. So without any further ado, we will now be starting with our presentations for today. So our first presentation will be done by Akbar Kushanur from BITS Pilani in India. And the title of the research paper is Melanoma Cancer Detection in the Artificial Intelligence Era. existing CAD systems, challenges, and future research paths. Sir, I request you to kindly start presenting. Thank you.
Sure. Thanks, Amoga. Thank you. Let me share my screen. The screen share is get disabled, Amoga. Can you please enable me?
I have did it just now. Can you try once more? Are you able to share your screen,
Yes.
sir?
Yes.
Okay,
Let me know once you're able to see my screen.
sure.
Okay. Thanks, everyone. Good morning. Good afternoon. So I'm Kushanur Akbar. So currently pursuing my PhD in BITS Pilani Goa campus. So today I'm going to be walk through about one of our research paper, which is get accepted in ICTIS. So the title is Melanoma Cancer Detection in Artificial Intelligence Era, Existing CAD System. What are the challenges and the future research paths? So this research work is going to be carried under the supervision of Professor Sanjay K. Sahai sir and the Department of CFC. So today outline of my research work is introduction and public data sets and the benchmarks which are available and the deep learning models for melanoma detection, explainable AI in melanoma cats and conclusion and future work. Yep. Coming to introduction, so skin cancer is one of the most prevalent type of cancer in worldwide. So it's not able to see in our Asia region, but in US, UK, and New Zealand, we are able to see more frequent diseases is going to be happen. And year over year, the mortality rate, that means the death rate of melanoma skin cancer is going to be increasing. So because of that, we need to focus towards how early we can detect the melanoma cancer. So the early detection is going to be save the human lives. So that makes us to be focused towards to the melanoma detection, correct? So previously in olden days, so we have the traditional clinical methods. So dermatologists used to go with a set of predefined rules like ABCD is one of these popular method they are going to be used. It used to be identify the skin lesion based on the asymmetric border, color, and diameter, how much it gets spread, and then you will go with the specific evaluation criteria, correct? So those methods is going to be completely relied on a specific person and the expertise how long they are going to be work on the specific module. So latter years it get evaluated. There is a dermoscopic lens get introduced, so which will give the more visualization on the surface of the skin structures. There also they are going to be applied to the ABCD rule and different 7-point checklist and all. They're going to apply it. They're going to identify the melanoma detection. So these are also again related on the expertise of the dermoscopic, how more experience on the specific tool the dermatologist is going to do. So based on that, it's going to do. If the person will get changed, some may not become as an experienced dermatologist used to be do, correct? So latter year, there are going to be a couple of imaging modalities like hyperspectral mechanisms, total body provided some of the insights, but these are very complex and it need to be a lot of diagnostic space and the clinical environment. So then the computer-aided diagnostic systems like CAD systems is going to be enabled for the clinicians to enable their whatever the handcraft features they're going to evaluate. Similarly, these tools is going to be help to the dermatologist to do that. But the availability of data sets is very small and it providing the outcome is also very poor actually. So then latter years, the deep learning models is come like CNN and visual transformers get improved the accuracy of the CAD systems as like dermatologist, but it need a lot of, sorry, it focused more on the specific isolated images. It's not having the broad set of data or not, correct? So these challenges also based on the data sets what we are going to be used. If dermoscopy is the previous one, if any new tool is came, that means the domain shift is going to be happen. Because of these things, again, the models is not going to be provide any fair decisions to us. It will be completely not relied on the model. It also relied on the data sets what we are going to be using, correct? So and the another challenge what we are able to see is whatever the models of the AI which we are going to be used is every model used to be provided as a black box. We are not aware what is the why the model is taken up that decision and why it need to be classified as a melanoma. So that clarification we are not getting it. So that makes us a lot of inconsistency in the FDA regulations. So we are not going to adopt any AI system in the healthcare environment, and it lacking with the clinical trust and slowness in the clinical adoption. So these are the two things is going to be raise the concern. So when it comes to the public data sets and the benchmarks, what currently it is available, so early 2000s, so it is very small and single center of hospitals used to be provide the dermoscopic images. It's not going to be enabled to anyone, only the specific set of people used to be access and then do their research actually. So this means the generalization and diversity for clinical applicability is very limited. And latter years in 2015 onwards, so there is a ISIC, International Skin Imaging Collaboration organization get established, and it get collected from dermoscopy images about the skin cancer from different hospitals and different organizations. So that get it makes standardization of the data sets, correct? So each data or image which is get available through this is a certified skin cancer, so that will help us to be do more research in the digital aspect. And the data sets like HIM 1000 is enable the multi-class scale of the data sets actually. And recently there are a couple of modern data sets is came, Derma 7 PT, PAD, UF, etc. These are the generic data sets which some of the things instead of dermoscopic lenses, we are going to be use the smartphones to collect the data, correct? So this will give the complete diversity from what usual clinicians you do. This will give the generalizability, and tomorrow you can capture using your mobile, and then you can upload it and you can understand yourself without taking off any help of the dermatologist whether your lesion is going to be formed as a skin cancer or not. If it is forming skin cancer, what type of skin cancer it used to be. So that generalizability is coming up. And Fitzpatrick's 17K is another data set which is going to be give the diversity and fairness. So if you see entire region to region, the skin tone is get changed, correct? In United States, the skin tone is very fair, and in Asia region, the skin tone is somehow manageable. That means the darker than US citizens. Then in the Western Africa region and all, so we have the different skin tones. So correct, it used to be give the skin tone diversity also we can do with the help of these things actually. So there are additional data sets is also get emerging. That is a total body scanning and all, 3D total body scanning and all is going to be enabled. Different set of research we are going to be focused towards. So these are the current evaluating data sets, and this is the overall each year how the data sets is going to be. So overall across these data sets, ISIC is the standard one. So it has a huge 100K plus of images, and it used to be support multi-class lesions actually. HIM will support 7 classes, PH2 will support 3 classes, Derma 7 support along with this. So overall these things, PAD UF20 is a different data sets where we are going to get the day-to-day evaluation of the skin lesion about the smart price. It will give the images along with the clinical information, what is the age of the person, and what is the mole size and how it get evaluated, and all those details also will give. So that will give more real world adoptions. We can build the system. So this data set will help us actually. So the overall evaluation of the deep learning models for melanoma detection, here it is going to be focused. Early stage, it used to go with the handcrafted features, then CNNs come into the picture. Once the ISIC dataset challenges is get onboarded, the CNN, we are going to be evaluate very advanced models we are going to use. Then later it go with the transformer models, it get into the picture, correct? So then in the 2020 to 2024 era, we are going to be more working on the multi-model learning and longitudinal model learning. So here more instead of clinical, we are going to be more relied on our smartphones, and dermoscopy metadata is going to be enabled to put the different directions of the research actually. And future direction from 2025 onwards, we are going to be the research is going to be evaluate in the part of total body. Instead of focusing on specific lesion, it's going to scan entire your body where the lesions is get formed and what the things is to be, you can focus it, correct? And along with that, explainable AI. So wherever the model used to be give the decision for you, it used to be evaluate what decision is behind and why the model is pick it up the decision and all. So that used to be go towards to the explainable AI. Longitudinal to the total body coherence. So it also give for the total body evaluations. Along with that, we are going to be evaluating based on with the help of AI. We are always looking for the personalized medicine suggestions based on your mole size and all those things. That factors also putting the different directions of the research actually.
Excuse me, sir.
So coming to sorry.
Just a reminder that you have 2 more minutes of presentation time. Thank you.
Yeah. I'll wrap up today. So,
Okay.
yeah. So as explained, the CNN models, and it has to go with the dermatologist level classification used to be do, and it need to be focused specific images, and still it has the black box nature. Vision transformers still going with the attention level. Each the hierarchical reading of the structure, reading of the image get patterns get changed, but still it need high computational and large data sets is need to be looked at, correct? And interpretability and reliability is still challenges even you are going to use this. The multi-model is going to be image plus clinical metadata that help to the patient's information. Again, it going to be put a different direction of the research, but still it also lacking about the larger scale of the multi data sets are still not available. And longitudinal sort of total body scanning and 3D imaging also evaluating, but it is only the specific patient centric information, but it also have the limited data set, but it is very difficult to adopt into the clinical practices actually. So then to avoid the black box nature across whatever the models it get evaluated, there are different type of explainable things is coming into the picture, and silency based methods and class activation based methods, which is going to be highlight the specific region where the dermatologist used to be focused, but still it has a unstable, and sometimes based on the data set, if you're changing it, then it will uh, put a different direction of the image highlighting it going to be highlighted. So this makes to trusting of the model region, and the visual plausibility is also still challenging with the help of these methods actually. Attention methods and prototype based approaches like transformers which get used it, but these are the methods also still having the challenges on the explainable decisions based on the existing cases and how it get enabled to us, and it lacking with the richer explanations and all. It's still having the challenges, and also whatever the explanation it used to be provided, we don't have any validation rules how we have to be evaluate the explanations, so they're also challenging to us. User studies and trust of regulations. So it used to be provide improve the clinician confidence and the diagnostic performance when explanations align to the specific clinical region. So these patterns are still evaluating, but sometimes what it will do, the patient metadata also, we have some misleading concepts will be coming to the picture, and we are not going to be complete the regulators like FDA. We are not going to be complete the AI system in the healthcare system. So that is the still challenges, and we have to be focused towards the human centric of the AI systems. So the conclusion and future work of our research analysis, artificial intelligence is more and more, it is growing, and it's still achieving the dermatologist level classification, but still we are facing with the challenges of the trust, and clinical adoption is another challenge we are going to get it. Along with that, the data sets which are get available that need to be standardized, and when it is coming to the new direction of research is focusing, but we need the new side of the data sets also need to be standardized. So that is a big gap in the current research actually. And our research is more focused on image centric, and based on the existing models we are going to be trying, but there is no generalization across the data sets we are not going to be populated. And if you build today dermoscopic of research is running it, tomorrow if you switch to the smartphone, that generalization we need to be adopted. So these are the very real world settings when we are going to do the clinical adoptions. So interpretability remains a major challenge, and many explanations do not align with the dermatologist criteria, and we have to become with the right research, right validations of the clinical trust. So we need to enable it, correct? And future research must be focused on multimodal, longitudinal, and patient-centric frameworks. So ensuring it need to be go with more robust and fairness of human AI collaborations is required for the more real-world adoptions. Yeah, thank you. I'm happy to take any questions if you have.
Thank you so much for your presentation, sir. I now request our session chairs if they have any questions for you. Dr. Kare, any questions for our speaker?
Yes, first of all, good presentation. So it is related to only the survey, or have you implemented any module for it?
Yes, this is a survey paper, and I have implemented a couple of papers to get published as well, madam. So we did explainability is one focus we did. We introduced one new model for this. Along with that, I have coming up with the validation rules, how we want to evaluate the explanations. So that area is still evaluating. So our focus towards the explanation, and how could I trust if even if model is giving the explanation, but how could we do that? And another model we get implemented along with the image visualization explanations. We are giving the text explanations actually. So that means even ordinary persons who are not expertise in the dermatology, they can understand how the model is giving the decision and which are the areas is getting impacted to identify the specific skin cancer. So that also is another direction we implemented the things actually.
One question, so there are already a clinical trials and clinics are available in many countries. So how far
Yeah.
your model will be trustable for the customers?
So that's what we are going to be enable the accuracy along with the model decision. We are giving it one part and what is the confidence of the model it is giving it. Along with that, we are enabling the explanations why the model is taken 90% of accuracy of that model and what makes the model to take the decision. We are going to give the dermatologist level explanations, correct? So as I mentioned initially, the ABCD is one of the primary criteria and popular criteria is going to be used in the dermatology world. So that criteria we are aligning our model explanations, correct? So your model is your lesion is asymmetric and you are able to see the two different colors in your lesion and your lesion length get expanded more than 6 mm. So these are the different dermatologist criteria we are embedding into in our model, and that model is going to be give that explanations to understand it, correct? So we are in simple layman language, we are incorporating the dermatologist clinical practice method into in our model to evaluate the lesion actually. It should not be go simple train and test the model and then enable the results. So we are not doing that.
Okay, and how far has the melanoma spread within or beneath the skin?
Sorry, madam, I lost.
How far has this melanoma cancer spread? What will be the time period for it? How much time it is going to take to spread in
So
the
it's
body?
more than, yeah, if we identify prior 1 month, so then it is good to taken up the treatment and then we can go off with the melanoma cancer. If you neglect that one, it will spread into the different organs actually. So it's just the time period is primarily 3 to 6 months is spreading time period. Then after that, it will start spreading into the different organs.
Okay, all right. That's it from my side.
Okay, thank you, ma'am. Any other questions for our speaker? Okay, we can move on to our next
Sure.
speaker then.
Thank you, Amok sir.
Thank
Thank
you.
you so much for your help.
Yes, thank you. Thank you for your presentation. Thank you.
Thank you, Abba, for the presentation.
Yes, so the next presentation for this session would be done by Tan Phuong No. I apologize for any mispronunciations. From the Tieng Giang Medical College in Vietnam. And the title of the research paper is A Low Distortion Reversible Data Hiding Method for Dual Images. Sir, I request you to kindly start presenting.
Good afternoon, everyone. My name is Ngô Thanh Phương. Today, I will present a low distortion reversal data hiding and method for dual image. This operation has 5 facts. One, introduction to related work. 3, proposal method. 4, result and 5, conclusion. Introduction: reversal guiding embeds data into an image while allowing perfect recovery of the shaded data and the original image. A good ADS method shall achieve high embedding capacity and high image quality. However, single image ADS is critical to balance AC and BSNR and complex processing step in real distortion and conversion time. Hence, a better ADS method is needed. Related work. This is table 1 summary of ADS under key knowledge lecture and everything. The method enlarge achieve medium AC and medium image quality and achieve medium AC high image quality. Introduction achieve high AC and high image quality. Dual image to a very high EC and high image quality. The automated device direct center shifting on select data, simulate your image embedded achieving very high EC and high image quality. Performance. We apply center shifting directly to select data. The first we divide data into L bit segment, and next we shift related to center, and then we distribute it into stereo image copies. A result, the report can review distortion and keep high C and simulate the algorithm. Embedding. This is figure 1 chart of the data embedding process. Given select data, data E. First, convert E to binary. Next, segment binary scan and convert to decimal. Then perform center shifting. After that, separate shifted related to component X1 and X2. Meanwhile, original image I read image copy I1 and I2, and next add H1 to copy I1. We get still image I1 run. Similarly H1 to add to I2, we get still image I2 run. Example of data embedding process. Event select data E, original official page, control system level U, number of feet V and U, where the number of hits to represent select data and L is number of bits of bits for segment. The first convert E to add bit binary net segment into 4 bit groups. Then convert decimal. After that, perform center shifting. Net split into component. Finally, embed into original official V1 and V2. We obtain stereo image. Recovery. This is figure 2 flowchart of the select data and image recovery process. Given stereo image I1 run and I2 run. First, recover image and original image I. Next, extract value. Next, recover decimal value. Then cover to binary segment. Then connect binary segment. Finally, select data A. A symbol of data adjustment and image recovery. Event stereo official P1, P2, and relay U, L, and P. The first recover P. Next, compute X1 and X2. Then recover C. And then the recovery. After that, convert to binary. Finally recover E. Result. This is figure 3 for image used in the experiment. That's image. Add striker image 5, 1, 2 by 1, 2, A, B, C, D, E, F, C, S. This is table 3, comparison of AC and reaction of the automated with assistant method. We can see that both methods have similar AC. Both robotic methods E hay IBS and R in mod image show the robotic natural with the image quality with high embedding capacity. And this is a table trade comparison of average AC average efficiency for one gene reaction among different methods. We can see that at the same AC equal 2 PPP, the robotic achieve at high IBS and with millimeter image quality. This is a figure for comparison of the average reaction value of that image on the different research. Red, we get that we red line robotics and blue line select and trend. We can see the robotic red line high BS and Atmos AC lower. Conclusion: do image RDF using center stain on the shared data advantage high AC good fit and simple algorithm for the recovery of image and data. Application: skill image storage and skill image transmission. Thank you.
Thank you so much. Thank you so much for your presentation, sir. I now ask our session chairs if they have any questions for you. Professor Abdullah, do you have any questions? Dr. Kare, any questions for our speaker?
Yes. Actually, I would like to ask, what is the application of your work? How it is useful? Am I audible, Amok?
Yes, ma'am, you are audible. Hello, sir. Were you able to hear ma'am's question?
Okay, all right, Amok. Take a next.
Okay, no worries. Thank you so much for your presentation, sir. We can move on to the next presentation. So our next presentation will be done by Sarvana Gukhan P from the Dr. Mahalingam College of Engineering and Technology in India. And the title of the research paper is A Robust Deep Learning Framework for Automated Diabetic Retinopathy Detection and Severity Grading. Sir, I request you to kindly unmute yourself and start presenting. Okay, I think he hasn't joined us yet. We can move on to the next one. So our next presentation will be done by Amol Dhumane from the Symbiosis Institute of Technology in India. And the title of the research paper is ADAX Optimized Deep Convolutional Neural Network for Automated Detection of Age-Related Macular Degeneration from Retinal Fundus Images. Sir, I request you to kindly start presenting.
Yes, good morning. Good morning, all. Should I start?
Yes, sure.
Yeah, give me 1 second. I'll share my screen. I hope it is visible.
It's still loading, sir.
Not yet, sir.
Yeah, now it's visible.
Yes, it's visible.
Yeah. So the title of my paper is Automated Degeneration of Age-Related Macular Degeneration from the Retinal Fundus Images. Normally, this is a type of disease that normally occurs in the people above 50 years age. and their vision gets blurred, or we can say that distorted due to that retinal infection or problems. So there are two types in this case normally. The first one is called as dry AMD, which is common and it is having slow progression. And the second one is called as wet AMD. So that is rare, but you can say that the vision loss takes place faster compared to dry AMD. This is an eye disease and that affects the macula of eye. The macula is, we can say that it is a central part of the retina, and due to that the vision problems takes place. So that is what the idea, overall idea. So for that, this is what the related to the disease. I hope that due to the time limitations, I will directly talk with the uh, technical details. So now, in this case, actually, we face that if we use any neural network, any type of neural network, so that time the problem happens at model training, and the second problem may occurs during the hyperparameter optimization. So that's why we have broken the research into two parts. The first one is hyperparameter tuning, and second one is actual working of the model. So in hyperparameter tuning, we have selected certain parameters and we have optimized those parameters based on the ADAX optimization techniques. Normally, when we talk about any bio-inspired optimization techniques, so in that, using the meta-heuristic approach, these techniques try to find out the best solution from the given sample set of solutions. So the same thing is happening over here. We have taken 6 to 7 parameters, and these 6 parameters we are finding out, we are creating a solution set from these 6 parameters, and we are trying to find the maximum probable best solution from that solution set of parameters, and then we are applying it on our model. So that is what the concept is. So in this case, we can say that, as we know that CNN model gives powerful feature extraction techniques, but the challenge is related to hyperparameters as well as the model tuning. And as this application talks about is having, rather we can say, clinical liabilities. So obviously, if the results are wrong, then you can say that it will be treated as a very risky thing. So that's why manual tuning problem we can handle it using manual tuning problem, but the problem is that in that case we need to try out in n number of ways, more efforts we need to put, and maybe we might not be sure with the results. So that's why for doing the optimization, for selecting the best parameters, we have selected the ADAPS optimization technique. Then this is what the ADAPS optimization techniques. In that, normally in this algorithm, ADAPS is like a deer, we can say, antelope, which moves into the deserts and try to find out the scarce resources such as food and water. And while approaching to that problem, the ADAPS or that antelope, or you can say that the deer, try to use its natural intelligence, and then it tries to come to closer and closer to the problem by exploring the entire search space. So that is how this ADAPS optimization algorithm is there. So similar theory we have used in our problem for finding out the parameters. So now, in that case, we have used data set which is called as ARMD data set. Normally it is available actually on Kaggle. We have downloaded it. That was a very good data set. People have done huge experimentation with the help of this data set. So we have preferred that, and less pre-processing we have done because that is like really a standard data set. Then after that, we did the parameter selection, and then we executed it into the clinical environment. The model is executed into clinical environment. In this case now, I will, let me, this thing, what is that? PPT is visible, right?
Yes, sir. Yes.
Okay. So this is what the exact face. Here, if you see, raw image is there. That raw image is resized and standardized. Then we have used clad enhance technique. So these dotted spots or these bright spots are there that we removed by using this clad enhancement technique. And then with the reduced noise, this image we have received. This CLA is called as contrast limited adaptive histogram equalization technique. That actually enhances the brightness of the medical images. It puts contrast into that and it just highlights these veins and all. And whatever the part is required on the basis of that, we need to do the diagnosis. So that part is focused with the help of this particular technique. So it makes what you can say that disease related patterns more visible. Then we have obviously we have splitted this data set which was containing 1800 something images. In that 1000 images, 800 images were normal images, and I think 1185 images were the AMD related images which were containing the actual disease. When we have normalized, we have enhanced this image, then we have divided the dataset into three things, that is training dataset, validation, and testing dataset. 70% of the part was training, 15% was validation, and 15% we use for testing purpose. So that proper split we ensured. After that, these are the 6 parameters that we tried to tune with the help of Addox optimization algorithm. In that, learning rate was there, batch size was there, kernel size was there, filters were there, optimization types were there, dropout ratio was there, or rate was there for making the model stable. This is how your Addox optimization was working. This was working with the help of this equation. We designed the solution set, 10 probable solution set, and from that solution set we tried to find out the best solution, where 2 phases are taking place. First one is called as exploration phase, and second one is called as exploitation phase. I'll tell you in simple way. Exploration will be the phase where we try to find out the problem at a larger level throughout the solutions, where we try to approach each and every solution to find out which will be the probable solution. And now when you come towards in terms of that antelope, we can say, if when it comes near to the solution, that time it faces some hurdles, then that algorithm automatically goes into the exploitation phase. There we go closer to the solution, but some problems happens, and that are always handled with the help of this tension vector or this R1 parameter. So then again, after finding out the fitness of every probable solution, we have used this fitness function, and that fitness function was containing alpha and beta. This fitness function has given us helped us to finding out the probable solution, right? Where accuracy, in this case, the accuracy is measuring overall correct predictions of the CNN model. F1 score balances the precision and recall, and the loss indicates the prediction error. And here some parameters are given, like alpha, beta, and gamma are given. These are the weights that are used to control the importance of each of the objective, and it helped to achieve, we can say that, balanced and clinically reliable results. So that happened with the help of this fitness function. With that, we got the actual parameters, and that parameters we have applied to the ResNet 50 network, and the ResNet 50 network has performed, and it has given us the layer. It has given us the actual results. So if you observe the area under the curve, it is approximately rather very close to 1. So it means that the accuracy of the model was good. And these are the results. We compared the results with a couple of other models that we also
Excuse me, sir.
Yes.
Sorry to interrupt, but just wanted to give you a reminder. You have 2 more minutes of presentation time
No
left.
problem.
Thank you.
I'll finish in 2 minutes. No issues.
Okay. Thank
So
you.
if you see the results, in that Addox CNN is performing very well. So the accuracy is higher, precision is higher, recall is better, specificity is also good, F1 score is also good. So overall, we can say that the area under curve that we have seen in the last slide was approaching to almost 1. So this is how the performance improved. And then we can say that this algorithm, when we compare with the other algorithm, so it was performing good. The accuracy that we got in this case was 96.4%. So that's it from my side. Thank you. If you are having any questions, please let me know.
Thank you for presenting, sir. I now ask our session chairs if they have any questions for you. Dr. Kare, any questions for our speaker?
Yes, sir. What is the use of a fitness function in your work?
Yes, ma'am. So normally what happens when we train any convolution neural network? So that time we need to select the parameters, right? So for selection of the parameters, we have lots of options. So we can either tune the parameters manually or we can tune the parameters by using some technique. So the fitness function will tell me the strength of the parameter, how much that parameters are good for giving to the CNN or in this case ResNet 50 network. So for finding out the fitness of those parameters, we have used the fitness function.
And you mentioned that ADAC CNN has given the better result than the other algorithms, but there are many other three algorithms that you have mentioned that are giving the good output as well. So it depends on the case or on the data set.
It depends on the case, the performance of the algorithm. See, the thing is that baseline CNN is there, PSO is there, GA is there. So all these people are also, all these algorithms are also performing. The results are almost close to ad CNN. But the thing is that the way we have tuned the parameter is probably better, and due to that, we got the good results.
All right, that's it from my side. Thank you, sir, for your nice presentation.
Thank you, ma'am. Thank you.
Professor Abdulla, do you have any questions for our speaker? Okay, I think she isn't present. No worries. Thank you so much for your presentation, sir.
Thank you very much. Thank you, ma'am.
We now move on to our next presenter for this session. So our next presentation will be done by RVE Pagzad from the De La Salle University in Philippines. And the title of the research paper is Classification of Tree Species in the Philippines Using LiDAR UAV Data. Ma'am, I request you to kindly unmute yourself and start presenting.
Hello, good afternoon.
Very good afternoon, ma'am.
Very good afternoon.
Okay, good afternoon, everyone. I am Army Pakzad. I will be presenting our research titled Classification of Tree Species in the Philippines using the LiDAR UAV data. And my co-authors are the following. Nathaniel Adrian Kuwa, Louis Ke, Alvin Josh Valenciano, Jana Johannes Valenzuela, and Dr. Abbas Ali Pakzad. We are from the De La Salle University, Manila, and Laguna campuses in the Philippines. Okay, so this is the outline of my presentation. I have here the introduction, the objectives, the methodology, the results, the conclusion, and the recommendation. Okay, so urban tree canopies provide measurable ecosystem services, such as mitigating air pollution, regulating stormwater, and contributing to human health outcomes. Yet, in the Philippine context, comprehensive tree inventories remain largely absent. There is at present no reliable systematic record of what species populate Philippine urban forests or where they are located. Conventional inventory methods rely on labor-intensive ground surveys that are costly and difficult to scale. The rapid deforestation documented by Kummer and Sham in 2023 underscores the urgency of developing more efficient alternatives. This study investigates whether LiDAR data acquired through an unmanned aerial vehicle can serve as the basis for automated machine learning-driven tree species classification. These are the objective, particularly the general objective of our study. So our study aims to develop and implement a machine learning model utilizing UAV-acquired 3D LiDAR data to precisely classify tree species in the Philippines. And our specific objectives are as follows. Number one is to utilize LiDAR point cloud data to map the current tree locations and characteristics in a Philippine forest. And then second, to identify at least 5 tree species groups using machine learning with ground data validated by at least 2 forestry experts and obtain an overall accuracy and producer's accuracy of at least 70%. Next, a specific objective is to interpret the results from the LiDAR data that went through machine learning methods. And then another is to achieve a mean class accuracy and kappa accuracy rating of at least 75%, ensuring that the model demonstrates robust and acceptable performance. And lastly, to design and develop a user interface or UI for visualizing pre-processed LiDAR data, GPS coordinates, and tree attributes, providing outputs of identified tree species with corresponding visualization. Now, the review of related literature identified 2 converging areas of prior work. Okay, on tree canopy assessment methods, approaches including airborne laser scanning, Google Street View, i3, UAV RGB imaging, and image processing techniques have been applied to urban tree canopy measurement. And the LiDAR, combined with convolutional neural networks, object-based image analysis, and multi-segmentation algorithms has proven effective in both urban and rural settings, including, of course, the Philippines. On machine learning algorithms for tree classification, such algorithms such as the mask RCNN, CNN, KNN, weighted SVM, random forest, and light gradient boosting have been applied across various data sets. Though direct comparison across studies is difficult due to varying methodologies and data sources. Now here is our methodology. First is about the data acquisition. Basically, the study was conducted at the La Mesa Eco Park, located in Greater Lagro, Quezon City, Metro Manila, Philippines. It is selected for its ecological importance, biodiversity, and complex canopy structure, which is ideal for remote sensing classification. Then this is the data acquisition using the LiDAR data, where the LiDAR data were acquired using a DJI Matrix 350 RTK equipped with ZenMuse L2 sensor, flown at an approximately 100 meters above ground level. And then another method for data acquisition is the ground survey. Okay, so a total of 1,059 trees were documented, including species identification and GPS coordinates using a Garmin GPS map 64SX device under the supervision of forestry and site experts. Now, here is the block diagram of the development process, particularly the LiDAR processing. Now, for the LiDAR processing, the noise was removed and points classified into ground vegetation, retaining only classes 2 and 5. Outliers and duplicates were removed, elevations normalized in R, and intensity calibrated for consistent reflectance. Now, this is the ground survey pre-processing rather. This is the the diagram, which shows the flow of the ground survey pre-processing. So first is the correction of misspelled species, and each record was labeled with its scientific classification. Ground points were manually adjusted in QGIS to fix GPS inaccuracies, and the coordinate system was converted from WGS84 to EPSG 3123 to align with LiDAR data. Next is the system development process for the tree segmentation. Now, the tree segmentation involved three steps. The first is the canopy height model, or the CHM. It was generated using the highest point per area to represent the tree height. Then the tree tops were detected using a local maximum filter, and the individual trees were segmented with the Del Ponte 2016 method using a 45% height threshold. Then from the delineated crowns, features were extracted across three categories. The height features captured the three-dimensional structural profile of each tree. The intensity features quantify the radiometric return characteristics of the LiDAR sensor. And the terrain features characterize the local ground conditions beneath each crown. And together, these features from the numerical representation used to train and test the classification models. Now, in terms of classification, 8 machine learning algorithms were trained and evaluated.
Excuse me, ma'am.
Yes, sir.
Just a reminder that you have 2 more minutes of presentation time left.
Okay, thank you.
Thank you.
So we have the naive base, we have the XG boost, the K nearest neighbors X, we have the SVM, other boost decision trees, random forest, and logistic regression. Now, here is the UI development process. Okay, so a web-based tool was created for forestry experts and park managers. It uses leaflet.js for 2D maps and Poetry for 3D point cloud visualization, displaying color-coded models, results with access to individual tree attributes. Now, for the testing and evaluation, classification performance was evaluated using the overall accuracy, the kappa accuracy, and the producer's accuracy and the mean class accuracy. So the overall accuracy is the proportion of correctly mapped trees, while kappa accounts for chance agreement between predicted and the true species. Then the producer's accuracy measures the proportion of correctly mapped trees per species, and the MCA here is the average of all producers' accuracies across species. Now let us move on to the results and discussion. The study covered 19.86 hectares of La Mesa Eco Park using the EPSG 3123 coordinate system, and 10.31 hectares were retained after moving points outside the boundary, noise, and duplicates. Then a total of 1,059 tree coordinates representing 80 species were documented. Trees obscured by overlapping canopies were excluded, leaving 1,002 trees. The table here shows the top 10 species by count, of which the first 5, which are mahogany, nara, teak, raintree, and tibig, were used for analysis. Now, this is the tree segmentation for the canopy height model. After pre-processing, the CHM was generated, showing a smooth surface of canopy height variations that clearly highlights the crown structures and individual treetops. Okay, so here, the local maximum filter was applied to the CHM to detect individual treetops by scanning the raster and identifying the pixels. So the red dots here represent the ground truth obtained from the actual ground survey, while the green dots represent those detected by the filter. Okay, so the algorithm expands outward from each treetop using the CHM height threshold and crown shape to define the extent of each tree. So the area of each tree can be seen in the legend here at the bottom. So visually inconsistent polygons were manually corrected to improve accuracy. These finalized crowns were then used to extract the corresponding lighter points for each tree. And then this is actually the overlay. This figure shows the crown boundaries overlaid on the orthophoto for visually verifying the spatial alignment with the imagery. And then these are the sample 2D point clouds of the top 5 species, where each tree is represented by a collection of lighter points that form the basis for subsequent feature extraction. So as you can see here in this graph, the XGBoost, the logistic regression, SVM, random forest, k-nearest neighbors, and AdaBoost algorithms were able to achieve overall accuracy scores higher than the 70% value set in the objectives. This shows generally good performance over the entire data set as a whole. And then,
Excuse me, ma'am.
yes, sir.
I'm really sorry, but your presentation time is up. If you can quickly conclude, it would be great.
Okay, so basically for our conclusion, overall, the best performing model was the XGBoost, achieving an 85% overall and kappa accuracy, 82% mean class accuracy, and producers accuracy in the range of 77 to 91%. This suggests that the further studies may be done to make use of the XGBoost algorithm in other tree classification studies. The paper was also successful in showing the development of a user interface to allow for the interactive viewing and the presentation of the results. So if further studies on this topic are to be conducted, the researchers' recommendations are as follows. First, the algorithms and workflow described in this study may be used on a larger data set with more species to test how it would scale, and deep learning architectures instead of traditional machine learning algorithms may be tested to see if they would provide better results. The addition of physical and or spectral or hyperspectral features could improve upon the model's accuracies. Thank you for listening.
Thank you so much for your presentation, ma'am. I now request our session chairs if they have any questions for you. Dr. Kare, any questions for our speaker?
Yes, what is the application of your work?
Well, basically, it could be useful for urban planning, okay? And, because in the Philippines, as far as we know, we do not have that, what do you call this? We do not have that inventory or proper identification of the tree species. And it also helps government identify where trees are located. It also supports green space planning, and it can assist in reducing urban heat and pollution. It can also be good for environmental monitoring, like tracks biodiversity. It can also aid in monitoring the deforestation and forest changes, and it also helps assess ecosystem health. And for maybe probably for disaster risk management, basically trees help prevent flooding, soil erosion. So our system helps identify areas needing reforestation.
And how much time it took for the data acquisition of that much of entries that you have mentioned in your presentation?
Well, actually, it took like 1 to 2 months of a survey.
And which UAV platform you have used for your work?
I'm sorry.
Which UAV platform you have used for your work? Which tool have you used? Like it's a drone or
Yeah, it's a drone. It's a combination of what do you call this? Yeah, it's a drone with sensor for the survey. It's an aerial survey, and then there is a ground truth survey which was conducted as well.
yeah. Thank you. Thanks for the nice
Thank you very
presentation.
much for those insightful questions, and thank you for listening to my presentation.
Thank you so much for
Thank
presenting,
you.
ma'am. It was a great presentation.
Thank you so
So
much.
we move on to our next presenter for this session. So our next presentation will be done by Akhil P. from the International Institute of Information Technology in India. And the title of the research paper is Clinical Guided Region Level Graph Transformer for Alzheimer's Disease Stage Classification. Sir, I request you to kindly unmute yourself and start presenting.
Yeah. So am I audible?
Yes, sir, you are audible.
Yeah, share screen. Okay. Good afternoon, everyone. So my name is Akhil. So I'm presenting our work title, Clinical Guided Regional Level Graph Transformer on Alzheimer Disease Stage Classification. So this work is basically carried out under the guidance of Dr. Mallikarjun Rao. So in this research, we focus on improving the accuracy and interability of Alzheimer disease stage classification. So we have integrated the MRI data with the clinical features using a graph transformer-based approach. So let me briefly outline the presentation. I will start with introduction, motivation. These are the content that I'm going to cover on. So this is the introduction. So Alzheimer, as we know, basically damages the brain cell, which affects the memory and thinking ability over time. But because of this progression is irreversible. So detecting the stage early become very important for proper treatment and planning. So we typically depend on MRI scans to observe this tragical change in the brain. But however, even though the deep learning models are widely used, they still struggle to fully capture the, as we can say, the complex relationship between the different brain regions. So yeah, so existing model, especially CNN model-based approaches, treat all brain regions equally without focusing on the decision-specific area. They also struggle to capture the relationship between the different brain regions, as you can say. To address this issue, our motivation is to learn the regional level representation and model interaction between brain region and using a graph-based approach. So additionally, we incorporated clinical information to guide the model attention, making the prediction more meaningful and clinical relevant. So yeah. So despite recent advantage, existing models still have several important limitations. First, they treat all brain regions equally without focusing on disease-specific area. They struggle to capture the relationship between the different brain regions, which are important in Alzheimer progression. And the fusion of clinical and MRI data is often, we can say that, too simple and does not fully utilize their combined potential. So the most model lack interoperability, making it difficult to understand their prediction from a clinical perspective. So this is our proposed framework. So first we have done the pre-processing. So here we have MRI images we have taken, we have normalized it and prepared where clinical data is also clean and scale. Next, we have extracted the features from MRI using our deep efficient net model BNet7, and clinical features are also processed in parallel. So these features are then combined using a cross model mechanism. So where, as you can see, where clinical information help guide the importance of different brain region, you can say. So finally, we use a graph transformer to model the relationship between the brain regions. So enabling better context-aware learning and perform, as you can say, the multi-class classification of Alzheimer's stages. So this is the methodology we have covered. So I have explained it earlier. Okay. So this is the data set we have taken. We have used the OSS1 data set, which includes both MRI scans and clinical data. So here we have taken 250 patients of each categories. So that data, as you can see, is categorized into 4 stages. That is non-dawn dementia, very mild dementia. So we split the data, as you can see, the training, validation, testing, to ensure the proper evaluation. And we have also used pre-processing technique as well, normalization, resizing, and augmentation for as well. So as on the right, these images represent different stage of the Alzheimer's disease. Yes. So this is our training and validation performance of our model. So on the left, you can see the loss decrease rapidly in the initial epoch and then stabilize, indicating efficient learning. On the right, as you can see, the accuracy basically increases and reaches a high value. Training and validation curve closely aligned. So this shows that basically the model is learning efficiently and generalizing well without significant overfitting. So this is our result and performance. So our model, as you can see, that achieved the best performance compared to other models. So it reaches an accuracy of around 90.15 and basically outperforming the model like ResNet, EfficientNet, and Vision Transformer. So we also observe a strong precision recall and F1 score indicating the balanced performance across all cases. So additionally, the model performed better in early stage detection, which is crucial for Alzheimer diagnosis. So the attention map further shows that model focuses on clinically relevant brain region, improving interpretability. You can see in the diagram. Okay. So next slide is about the conclusion. So we can see that we propose a clinical guided graph transformer for clear Alzheimer disease stage classification. Our approach efficiently combines MRI data with the clinical features and model relationship between brain regions. So this region is improved performance, achieving around 90.15 accuracy, which also improve better interpretability. So additionally, the model shows stable training and without significant overfitting. So this is the future work that we are going to carry it out. So for future work, we plan to extend this approach to larger and multi-center data set to improve the generalization and also aim to incorporate that PET fMRI for more improved diagnosis, as you can say. And finally, we plan to explore lightweight models to enable faster and scalable real-world development. Yeah. So thank you. Any questions?
Thank you so much for presenting, sir. I now request our session chair, Dr. Kare, any questions for our speaker?
Yes, actually, there are many patients, those are having Alzheimer's. So is there any chances by using your model that they can improve their Alzheimer's state?
Sorry, could you repeat the question again?
See, there are many patients that who are having Alzheimer, right? So what will be the chances that they can improve themselves by using your work that you have produced today?
So what we are doing is early detection means the Alzheimer's stages has 4 stages. Means if we are able to detect the early stages of the Alzheimer. So through this, our proposed model, it basically help in the early diagnosis on the basis of age, or we can say the mini mental state examination and CDR. So on the basis of that techniques, basically if a patient gives, so it basically helps them to analyze in the early stages only that if they have Alzheimer or not. So such that it can prevent them to move to the later stage.
Will it be curable if it is detected in early stage?
Yes, yeah.
And what would be the chances of it? Like 100%, or is there any percentage for it?
It depends upon the age as well. Means mostly the Alzheimer patients are around 60 to 70%. So if they are very, what we can say, if they do the things in a very appropriate way, then yeah, it could be curable, we can say. Also on the basis of their lifestyles and habituate, that also plays an important factor on it.
Have you concerned to any hospital regarding it?
Yeah, we have taken the ADNI dataset. So basically, ADNI dataset basically takes the dataset from the hospitals only. So it is of the Alzheimer patients all over the world.
In the literature survey, have you consulted the doctor and see, this is a very critical situation. In most of the times, it will not cure because I have seen such patients around me or in the relatives also. So it is, even if it is detected in the early age, it is not curable for certain cases. So what will be your future plan? So it should be curable for At least it should increase the accuracy and it should be curable to certain level.
Yeah, means our plan is to put the explainable AI as well, means on the basis of which diseases and which part is being more affected of the brain. So on the basis of that, we will going to see that analyze the brain very well. So,
All right, that's it from me, sir. Thank you.
thank you.
Okay, thank you so much for presenting, sir. We now move on to our next presentation for this session.
Okay, thank you
Okay,
very much.
so so the next presentation will be done by Olutayo VA from the Venite University in Nigeria. And the title of the research paper is Evaluating Online Shoppers' Behavior and Engagement Using Sentiment Analysis. Sir, so I request you to kindly start presenting.
Thank you very much. Once again, good morning, everyone. My name is Dr. Victor Akimbola Olutayo from Venite University, Iloro, Ekiti State. I believe you can all hear me.
Amog,
You are audible, sir.
Amog.
Yes, ma'am.
Wait, the presentation they're showing it is in very small screen.
Okay. Sir, actually, your presentation is, I believe, in a portrait mode. Can you convert it to landscape mode, please? So it would be visible on the entire screen.
Hello, can you see now?
Yes, sir, but it is quite small and it's hard to watch. So can you convert it into a landscape mode?
See, you are zooming in now, but
No, sir.
so
You are trying to zoom in, but I was just saying that if you could convert the orientation.
I'm actually using a particular device. I wouldn't know whether it's okay. Whether
okay,
it's
all
okay like
right.
this.
All right. It's
Can I go on like
hardly
this?
If you could please
it's
zoom out a little bit so that the entire thing would be visible. Zoom out, sir.
More?
No. I mean, you reduce it. You need to make it small so we can see the entire thing.
Oh, okay.
A little more. Yeah, it's now
Like
visible.
this?
You can start. Yeah, sure, sir.
Very good. Thank you very much. So,
Just a second. Dr. Kare, is the presentation visible?
it's visible,
pardon?
but it's visible, but let's see with the other slides. This slide is
Okay,
visible properly, but
sure. Okay,
Can I move
we
on?
can figure that out. Sir, if it's not a problem, you can send the presentation to me. I can present it from my side as well.
it's okay. How many
Okay.
presentation has remained?
Ma'am, after this, I believe we have two more.
Okay.
Okay, thank you. Sir, you can start presenting.
Thank you very much. So, my topic is evaluating online shoppers' behavior and engagement using sentiment analysis. Under the introduction, the rise of digital technology has led researchers and businesses to focus on technology and consumer behavior together. So, and this one has actually led to a vast generating a lot of data. Of course, consumer behavior and their methods of interaction were changed with the introduction of online shopping. So this behavior has actually led to the creation of a large volume of data that is useful, but yet to analyze. Now, sentiment analysis actually provides a solution to this problem. It allows the study of emotions within the text and provides businesses with necessary strategies to actually adapt to the needs of customers. So, the purpose of this our research is to actually culminate three distinct factors, including the increased including the increased amount of data generated as a result of customer behavior tracking online, the utility of sentiment analysis as a tool in the process of making strategic business decisions, and the ability to integrate theory with practice. In this regard, the study actually builds a sentiment analysis model based on the data of Nigeria's most popular online shopping site, for the purpose of this particular research. So, like we said, the unstructured feedback, the research focus, based on all of those things are partially highlighted. Now, the next slide, the research objectives now, that is the classify customers review from Jumia, that's the site we are talking about, into positive, neutral, and negative and sentiment using natural process language, NLP, and machine learning techniques. Then try to compare the performance of a bidirectional and gated and recurrent unit, that's GRU, the random forest need-based classifier on real-world e-commerce data. And the last one, which is part of our objective, is to extract actionable insight from sentiment pattern to help business optimize product services and marketing. Now, under the literature review, we review a number of papers, we know a number of related literatures which have actually worked on estimate analysis using machine learning. The Boys and Moons 2019 used natural language processing and machine learning to decode customer reviews effectively. And also the Panda 2016 also used positive feedback, boost engagement and loyalty. And then Liu 2012 also use sentiments, understanding, improve customer satisfaction in retail. But the problem statement and the gaps in their work actually did not actually cover the customer's perspective vis-a-vis the other part of the customer's perspective. That is, the social media sentiment data is insufficient because most of them actually centered on social media sentiment data, which is actually insufficient to capture customer sentiment data. Also, there is no holistic evaluation. They omitted customer perspective by solely focusing on online reviews. Also, classifying positive, negative, and neutral alone cannot actually capture mix on those emotions. Then, under the methodology now, we actually try to get our data through Kaggle. A lot of data has actually been generated from Kaggle, from that particular website. Now we try to collect the data collection, we pre-process it, then we extract the features that are relevant, then we now train our model, then before the evaluation, then we actually classify our data into two parts, the 80% for training and 20% for testing. So that's the part of our methodology. Then, under the sentiment analysis techniques now, under the traditional method, which is the lexicon-based analysis, which was simple, interpretable, but low resource, and cannot handle situations where we have biases and sarcasm, then context or nouns language. But under machine learning-based sentiment analysis, you have a model using need-based, support vector machine, that's RVM, random forest, and then bidirectional GRU. So they have a very better strength, the greater flexibility, the context awareness, the higher accuracy on complex data. The next one now is the bidirectional recurrent and unit architecture, which is major one which we actually use. Under this one, we have the several layers, the embedding layer, the dense layer, the output software under the architecture of our GRU. Now, the three models compare together because in our work, we actually use need-based, the random forest, and bidirectional GRU. So under this particular one, the probability classifier assumes feature independence with simple, fast, but limited with complex language. Under this need-based, then the random forest ensemble of decision tree with majority voting, more robust, handles noisy data better. Then the deep RRN processing sequence in both directions capture the full context and sentiment evolution under bidirectional unit. Now, the model performance now for the three algorithms, the need-based now asks about 67.4%. while that of random forest has 75%. But the bidirectional GRU accuracy has about 88%. So, which is actually the focus of our research, to actually compare about these three different algorithms to see which one actually perform better when it comes to opinion reviews under the computational analysis. And again, under the conclusion and recommendation, our key findings actually shows that the bidirectional GRU outperforms classical machine learning models, which has about 88.08 accuracy on Jumia customer reviews. Also, the deep learning captures contextual analysis that neighbors and random forest miss. Then the positive reviews derive purchasing decision. The negative reviews redirect customers to competitors, while the sentiment analysis enable data-driven product and marketing improvement. So the recommendation now we have is integrate real sentiment analysis into customer feedback system. Also explore transformer-based model for further accuracy gain. Then extend to multilingual and cross-platform analysis. Then address sarcasm and domain-specific jargons through transfer learning. And again, try to integrate real-time sentiment analysis. Thank you very much. Thank you for
Okay.
listening.
Thank you. Thank you so much for your presentation, sir. Dr. Kare, any questions for our speaker?
How many data sets have you used for this?
No, pardon?
How many data sets have you used for analyzing the behavior of the customers?
We use almost about 2,000 data sets.
2,000 data sets or 2,000 entries in the data set?
Hello?
She means to ask, did you use 2,000 data sets or 2,000 entries in a particular data set?
A 2,000 entry data set.
Okay, and what is the accuracy that you have got for it?
I've got to what?
What was the
Accuracy.
accuracy of those data sets?
Am I not audible?
Yes.
Your voice was a
Yes.
little low, ma'am.
Okay.
Yes, the accuracy of those data sets is what I've actually presented under the three algorithms. That is the name base.
Okay, all right, that's it from my side.
Okay, thank you so much for your presentation, sir. We move on to our next presenter. So our next presenter is presentation for this session then. So the last presentation will be done by Tiurida Lili Anita from the Bina Nusantara University in Indonesia. And the title of the research paper is Understanding the Adoption of AI Hotel Chatbots, the Role of Technology Readiness and Consumer Perceptions. Ma'am, I request you to kindly start presenting, please.
Hello everyone, thank you for the opportunity to present our study entitled Understanding the Adoption of AI Hotel Chatbots, the Role of Technology Readiness and Consumer Perception. This research examines how guests respond to AI-enabled chatbot services in hotels, especially by looking at the role of technology readiness and key consumer perception in shaping attitude and intention to use. Today, I will briefly walk you through the background of the study, the research gap and objective, the conceptual framework and hypothesis, the research method, respondent profile, measurement, and structural model result, followed by the discussion, implication, and conclusion. So, the hospitality industry is increasingly integrating artificial intelligence into service operation, and one of the most visible example is the use of AI chatbots. These chatbots help hotel manage booking inquiries, service requests, and guest communication more efficiently. They offer several advantages such as faster responses, better accessibility, and operational efficiency. However, the problem is that guest adoption is still inconsistent. Even though the technology is available and potentially useful, Not all guests are equally willing to use it. Some still prefer direct human interaction, especially when service situations require trust, require reassurance, or personalized communication. This is why it is important to understand what factors actually drive the adoption of AI hotel chatbot. The study addresses three main gaps. First, prior study often focus more on the technological or operational aspects of chatbots, while giving less attention to guest psychological readiness to adopt them. And the second, only limited studies combine technology readiness and consumer perception in one integrated framework. And the third, research in mid-scale hotels and emerging markets is still limited, even though those contexts are highly relevant for understanding real-world adoption behavior. Therefore, this study specifically examines AI hotel chatbot adoption in four-star hotels in Jakarta. The goal is to provide a more complete understanding of what shapes guest attitudes and intention in this context. The conceptual framework combines two major perspectives. The first is TRI 2.0 or Technology Readiness Index, which reflects a person's predisposition toward using technology. In this study, technology readiness is treated as higher order construct formed by optimism, innovativeness, discomfort, and insecurity. Sorry. Okay. The second perspective comes from time-related consumer perceptions, specifically perceived usefulness, perceived convenience, perceived information quality. These variables are proposed to influence attitude toward AI hotel chatbots, also directly influence intention to use. In addition, attitude is expected to affect intention and mediate several of these relationships. So overall, the model tries to explain chatbot adoption by combining psychological readiness with service-related perception. The hypothesis are grouped into several parts. First, the first hypothesis from A to D test whether the 40 RI dimensions significantly form technology readiness. Then the second and the third hypothesis examine whether technology readiness affect attitudes and intention. The fourth to the ninth hypothesis test the effect of perceived usefulness, convenience, and information quality on both attitude and intention. The 10 test the effect of attitude on intention, while the 11 to 14th examine the mediating role of attitude. The study used a quantitative cross-sectional survey design. Data were collected from 270 hotel guests who had prior experience using hotel chatbots in four-star hotels in Jakarta. The respondents were selected using purposive sampling to ensure that they matched the study criteria. The questionnaire used a 5-point Likert scale, and the data were analyzed using PLSM with Smart PLS. This method was chosen because it is suitable for testing complex relationships among multiple latent constructs, including a higher order construct such as technology readiness. For the result, in terms of respondent profile, the sample consisted of 54.8% male and 45.2% female respondents. The largest age group was 26 to 35 years, followed by 18 to 25 years old. Most respondents were university graduates and work in private sector. In terms of income, the largest group earned between 5 to 10 million per month. Most respondents stay in hotel 2 or 3 times per year. The most common chatbot channel used was WhatsApp or Messenger, followed by hotel website. Overall, the respondents can be described as young, educated, and digitally familiar users, which make them relevant for studying hotel chatbot adoption. Next, the result for the measurement. The measurement model showed good reliability and validity. All constructs had Cronband alpha and composite reliability values above 0.70, indicating good internal consistency. Most outer loadings were also above 0.70, which means the indicators represented their constructs well. In addition, the AP values were acceptable, supporting convergent validity. All HTMT values were below 0.85, indicating good discriminant validity. Overall, this result confirmed that measurement model was reliable and valid, so we could continue confidently to test structural relationship. For the structural model result, this provide several important insights. First, all four TRI dimensions significantly form the higher order construct of technology readiness. Second, technology readiness significantly influence attitude, but it did not directly influence intention to use. Third, perceived usefulness, perceived convenience, perceived information quality all significantly influence attitude. However, none of these three variables significantly influence intention to use directly. Another interesting result is that attitude itself did not significantly influence intention to use. For mediation, only two indirect effects were supported: perceived convenience through attitude and perceived information quality through attitude. In terms of explanatory power, the model explains 61% of the variance in attitude and 38% of the variance in intention to use. From the result, the findings show that the adoption of AI hotel chatbot is strongly shaped by both technology readiness and guest perceptions, especially convenience and information quality. Guests who are more optimistic and innovative toward technology tend to evaluate chatbots more positively. Likewise, when chatbots are seen as useful, easy to access, and capable of delivering accurate information, guests develop more favorable attitudes. However, the study also reveals an important attitude intention gap. Even though guests may evaluate the chatbot positively, that positive attitude does not automatically lead to intention to use it. This suggests that in hospitality settings, guests may still hesitate to rely fully on automated systems when they need trust, empathy, reassurance, or personalized interaction. So, a positive evaluation of technology functionality alone is not sufficient to guarantee adoption. The study offers both theoretical and managerial implication. The study contributes to hospitality technology literature by integrating TRI 2.0 and consumer perception variable derived from TAM in one framework. It shows that both psychological readiness and service-related perception matter in shaping attitudes toward AI chatbot adoption. It also adds value by identifying the attitude intention gap in the hospitality chatbot context. From the managerial perspective, hotels should not assume that simply implementing chatbot technology will ensure guest adoption. Managers need to improve not only technical performance, but also trust, psychological comfort, and the overall service experience. Chatbots should provide fast, convenient, and accurate information, but human support should still be available when guests need reassurance or more personalized assistance. A hybrid service model may therefore be more effective. In conclusion, this study shows that technology readiness, perceived usefulness, perceived convenience, and perceived information quality all play important roles in shaping guest attitudes toward AI hotel chatbot. However, favorable attitudes do not automatically translate into intention to adopt, which suggests that psychological and service-related barriers still remain. Therefore, the successful implementation of AI hotel chatbot hospitality depends not only on technological efficiency, but also on trust, comfort, and the service context in which chatbot is used. Thank you very much for your attention. I would be happy to answer any questions.
Thank you for your presentation, ma'am. Dr. Kare, any questions for our speaker?
Yes, I have one question. How do chatbots impact customer satisfaction compared to human interaction?
From the result of our study, the chatbot the chatbot seems they are using chatbot and they seem satisfied, but then the use of chatbot, it didn't make them feel secure to use the chatbot itself every time they have a reservation or booking or asking something to the hotel.
And how much data size do you have used for this work?
We have 270 respondents that reply our questionnaires.
Okay, through survey you have taken, or what will be the method for literature survey?
First of all, they don't trust this study, because they think that we want to judge them by if they can use the technology via chatbot or not. But later on, after we explain them clearly, they support our study.
Okay, all right, that's it from my side.
Thank you.
Okay, thank you. Thank you so much for presenting, ma'am. Well, that brings us to the end of session 8F. I now request our session chair, Professor Shaklo Rustamovna Abduleva, for her closing remarks. Hello, ma'am. Are you present? Okay, no worries. We can move on. I now request our second session chair, Dr. Rashmi Kare, for her closing remarks.
First of all, thank you, Amok, and thank you all the participants and authors. You have done really well. You have really done a well good job, and I would like to acknowledge the innovation and the research that you have shown here. The topics that you have presented, all are having a current trends, and we might even work it on it, and may go to the next level. But I miss hats off to all the participants. They have presented it so well, and thank you, Amok, for nice anchoring and handling the session so well. Thank you all the participants. It was really a nice session, and I am really pleased and uh, honored to be a session chair for this event. So thank you so much, all of you. And I request if we can click one group photo.
Sure, ma'am. We are going to do that. So yeah, I sincerely thank all of our authors and for the excellent presentations and contributions towards this session, and all of our participants as well for being a part of this conference. I hope this session was informative and knowledgeable enough for all of us. And on behalf of the entire team, I thank you for the support that you've shown during this 11th version of this conference and all the previous versions as well. And we will be more than happy to host all of you back again in 2027 for the 12th version. Just a small announcement, all the presenters will be getting their digital certificates via email within 2 to 3 working days. And the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICTIS. And I also thank both our session chairs for chairing this session. This is just a small token of appreciation to the chairs on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation as well. I now request all of you to switch on a camera for the quick snapshot that we are going to take. And we are done. Okay, thank you so much, everyone. Have a great day ahead.